In the morning session, we have discussed what is called as a synchronized method, and we have seen if you are not using this particular keyword called a synchronized, so the execution of this particular method, that means this particular statement, will be getting in a random fashion, right? And we have also said that the disadvantage of with this particular synchronized method is you are making a complete method as a synchronized, and that is not feasible in a cases when you have a more instructions need to be executed after this particular for loop, or if you have a more number of instructions within this particular method, right? So even though when a particular area is not concerned with respect to synchronization, that instructions also you are giving a protection by synchronization, right? So what I mean to say is, if so means in the morning session I explained you with respect to caravan example, so throughout, so means complete occupied method with respect to caravan may not be required to go with the synchronization, right? So some other places like a living areas or a dining table or a kitchen can be allowed for others to access. Only makeup, right? So makeup kind of stuff can be put in a synchronized part, right? So then there comes a picture of your synchronized block. Okay, so synchronized block is a simple. What we will be doing is whichever instructions we feel that synchronization is required. Okay, let me repeat a statement. Whichever instructions we feel that synchronization is required, only those statements you will be putting under a synchronized block. Okay, synchronized block is nothing but block of instructions, right? What kind of instructions it will be having? It will be having instructions wherein which you need to follow what is called as synchronization. Okay, so we will modify this particular program by using the synchronized blocks, right? So I said that in a method, if you are using a synchronized, there might be a possibility of some, we have copy pasted some 6 for loops, and we said why we have to wait until a completion of all those 6 for loops, right? So now what I mean to say is, for only this particular for loop I wanted to go with a synchronized block, right? So synchronized, right? Now I'll not be using a synchronized with respect to a method, rather I'll be using a synchronized with respect to this particular block, right? So this is not the end, I'm just showing you like this particular block I want what is called as synchronization. Okay, for this particular synchronized block, for after this particular keyword, here we need to specify one argument. Here we need to specify one argument. What is that argument? We need to pass on which object you wanted to perform synchronization, right? You need to pass object reference, right? So now with respect to which object you are going to perform a synchronization? With respect to caravan object, right? With respect to caravan object, I wanted to achieve what is called as a synchronization, right? So from there it will get this particular caravan object. Now from where it will get a caravan object, you have to pass by some means, right? So now what I mean to say is, here let me, so means for this particular method, let me have two variables, so means two values. One is the object, right, on which this particular synchronization will be applied, and another one is the name. Simple. Now with respect to this particular object C, you perform a synchronization. Any other changes need to be done? Yes, obviously there is some change need to be done. What is that change? How you called occupied method previously? So you called the occupied method previously just by passing this particular name, that means a string. Now it is expecting the two values. It is expecting a caravan also, it is expecting a name also, right? So I am saying with respect to this particular caravan, with respect to this particular caravan, with respect to this particular caravan, this block is synchronized block. Shall we check? Not much I think need to be worried about this particular thing, means with the block. Once you understood what is the synchronized method, simply we are just changing a method to a block. compiled fine, executed fine without intermediate answers. One, so means allocating a caravan, so means that particular block is executing with respect to one particular person. That means one particular thread, right? So even if I'm repeating it twice, it will be giving me a proper output. There will not be a mixed names, right? So this is called as synchronized block, where you are passing object as argument, right? You are saying that on this particular object I wanted to achieve what is called as synchronization. Any questions? Right. So now what I mean to say is, one way of achieving this particular synchronization was using a synchronized method, and another way was using a synchronized block, right? So with respect to synchronized blocks, you have two ways. One, either by passing the object as a reference, right? Here what we are doing, we are passing this particular object. We are saying that on this particular object, I wanted to achieve what is called synchronization, right? So you have a one more way also. One more way is, instead of specifying object, you can specify something called as class itself. What I mean to say is, whichever object has been created based on this particular class, right? So for those objects, you can go with the synchronization, right? So in this case, not to be specific with respect to object, you can tell that based on a class you follow what is called as synchronization, right? So be clear with whatever the modifications I have done. Just remove the class, just remove the object kind of a stuff, and introduced a class kind of a stuff. No errors, things are working fine, right? So point to be noted is, here with respect to synchronized block, two arguments can be possible. One is object. Object can be possible, on which object you wanted to achieve a synchronization. That is your first point. Second, if you don't know, so means you don't want to achieve a synchronization with respect to object, you want to achieve a synchronization with respect to class, then you can specify on which class you wanted to achieve a synchronization. You can specify that class also, right? When you are specifying the class, make sure that explicitly you are specifying class name dot class. Any questions? No, sir. That's very good. Thanks for the acknowledgement. Right. So that is about the synchronization topic. So the next topic what we have to discuss is one more very important topic with respect to a thread, that is this one. Inter-thread communication. So this is the topic which we have to discuss now. Any answers? What might be this particular inter-thread communication? By looking at a name, what you are feeling? What it might consist of? How different threads should communicate to each other? Beautiful. Any other answers? Okay, so let me explain. See, in a process, when you have a, see, whatever Tejkaran has said, that is a perfect answer. So I'm just elaborating whatever he said. He said in a sentence and making it as a paragraph or a pages. See, when you are working with a more than one thread, so there will be so many scenarios wherein which you wanted to know the status of other thread, right? So whether it is alive, dead, what's actually happening with respect to other thread. Okay, so then only your task might be completed. See, I'll just give you one scenario. You can imagine what might be the roles of threads with respect to that scenario. Say for example, you got a one notification, so means at your WhatsApp, you got a one notification saying that tomorrow there will be some notification delivered to you, hard copy of a notification will be delivered to you regarding the opening of a college, right? So even I am as much excited as you people, like when colleges will reopen, right? So that is the reason why I have taken this particular topic. Okay, so what I mean to say is, we are saying that, that means you got a message in a WhatsApp saying that you will get a hard copy of a notification, uh, by tomorrow evening, right? By tomorrow evening, around 5 p.m., right? So this message you got in a WhatsApp. Now when I say, when we receive this kind of information, obviously you will be eager to see what might be there in that particular hard copy of notification, right? So what you will do is, yes, they said like a tomorrow 5 p.m., right? Will you be having a general tendency whenever somebody, means outside, if someone is saying like a post and all, you will be having a general tendency whether that is belonging to my notification or not, right? That tendency will be there. That tendency, when they said by 5 p.m., it doesn't mean that exactly at 5 p.m. you will get that particular hard copy of notification, because it depends on a delivery person, courier person and all, right? Now the thing is, once it crosses a 5 p.m., right, even if there is a small sound outside, so you will be so eager to just cross check what means who made that particular sound, and did I got a notification with respect to that particular sound. Small eagerness will be there. Okay, so now what I mean to say is, now the person whoever is waiting for this particular hard copy, I'll call that one as a thread T1. Is a thread T1 who is waiting for the notification to arrive. Now there will be another person called a T2. His responsibility is to deliver that particular notification for you, right? Now the thing is, this particular T1 person who is expecting a notification, he cannot sit at the gate itself, right? If he is sitting at a gate, someone observes, then they will feel like, why this person is lying there, correct? Now what I mean to say is, this particular T1 should wait for some notification. That means the person whoever comes with delivering a content, obviously either he will make a phone call before arriving, or after coming at your location he will be shouting something else, right? Some notification will be given for you, right? So until he gets some notification, whether a thread 1 will be under a waiting state, waiting, he will be waiting for the notification, right? Now when a T2 comes, when a T2 comes with a notification, when a T2 comes with a notification, he will use a method called a notify. Notify in the sense, he will shout saying that, or he will ask someone saying that, where is this particular person, he got some hard copy of a notification from the college, right? So in this process of receiving some hard copy of notification, two threads are in action, okay? If a communication has to happen in a proper fashion, right, so then P1 should execute what is called as a wait method. Wait method means he has to wait, he should not bother until and unless he get a sounds, or until and unless he get a call, he should not bother about that particular task, right? Rushing towards a gate, he should not bother about that particular task of rushing towards a gate, right? Once he gets a notification, once somebody shouts his name, or somebody calls his name, somebody makes a ring saying that I'm outside your gate, please receive a parcel, in that situation he will be switching from a wait to another state, right? So what I mean to say is, if there is a two threads in action, that means if a one thread is depending on another thread, right? So there should be something called as inter-thread communication, right? Understanding a scenario, what I mean to say is, if a one thread, which is a thread T1 is waiting for T2 to give notification, right? If there is a dependability with respect to a thread's job to be finished, if there is a dependability with respect to a thread's job to be finished, then you will be hearing a word called as inter-thread communication, right? Shall we see an example how to use this particular wait method, notify method, or so means are there any other methods which will be helpful in doing this particular inter-thread communication? Got some interest? Okay, let us switch to the example. 1 second. Right. So here I didn't write anything, just a prototype of a class has been written with the main method. Okay. So now let me create one class my thread extends thread, right? Creating a thread. Now what is the job of this thread? Let us define a job of this thread, right? So let us make it something like this. I have a variable called int, and it is holding a value called a total. Initially I made it as a 0. Okay, so inside of this particular run method I will make, so means I'll write a small for loop just to calculate uh, n sum of n natural numbers. Okay, so total is equal to total plus I, right? So what is the job given for this particular thread now? So the job given for this particular thread is to calculate sum of n natural numbers. Simple, right? Now from the main method let us create a thread, right? So my thread th is equal to new my thread. Okay, th dot start, right? So after this particular statement how many threads you will be having? After a th dot start how many threads you will be having? After a th dot start how many threads you will be having? I'm not writing a code with respect to anything like a rocket science. Okay, so which has answer. Two threads, right? So one will be a main thread and another one will be a thread called a th. Yes, perfectly right. Now here let me system dot just a print whatever is the total value. Print ln of th dot total. Can I write something like this? th is object of this particular thread class. Yes, there is an instance variable called a total. By using that particular object I am printing whatever is the total value, right? So will there be any problem if I try to execute this program? What will be output? What is the answer for a sum of 100 natural numbers? It will run, sir. Okay, yes, it will run because we didn't do any syntax errors. But the thing is, what might be the output? Why I'm asking this question is, say for example, after this th dot start, you will be having two threads. One is a main thread and another one is a child thread, right? So now, if a thread scheduler decides that it has to give access to a main thread, right? So main thread will be doing execution. When a main thread does the execution, what it will print? It will print a system.out.println, right? So what will be a value of a total? It will be a 0 because first a main thread has got a priority. Correct. Now, say for example, if that is not happened, thread scheduler has a thought like there might be a something total has to be calculated. So first let us give a provision for this particular child thread to finish. So in that case, I will be getting a some answer 50-50, right? So what I mean to say is the sum of 100 natural numbers is a 50-50. This is the answer. Now I am not saying a 50-50 probability. I am just saying this is a value of a sum of 100 natural numbers, right? So what I mean to say is after this particular point, after this particular th dot start, if main thread has given a priority after this particular 18th line, if a main thread has given a priority, it will print a 0. It will print 0, right? If a child has got priority, if a child has given a priority, right, it might print a 50-50. If a complete execution is allowed, it will print 50-50 if a complete execution is allowed, right? If in between So means while executing 100 loops, if in between main thread has given a priority means it might be printing some random values in between this particular 50-50 also. Possibility is there, right? Correct. Are we establishing a dependability now? That is what our topic of discussion, right? Inter-thread communication, right? So there should be proper communication between these two. If not, then there will be some random answer, which we are not interested. Right? Shall we check, execute and check what might be the output? This particular example, I'll tell you how much interactive you will be, so that will be, so means it will be that much useful for you only. Java C, no errors with respect to compilation. What's the output it is giving? 0. That means parent has given a priority, child is not allowed to execute itself. 0, 0, 0, 0. Every time parent has given a priority, it is not giving a single chance for a child to execute. I am not getting even a 1 also as an output, right? So it is showing a clear evidence that child has not given any instance for execution. I just wanted to check will it print any intermediate values, but every time it is giving a 0 itself. Okay, so let it give a priority for a parent itself, that is a main method itself. What might be the solution now? How can we overcome that this particular issue? That means I want first a child to execute. I don't want a parent to execute first. What can be done at this particular place? Do we have any other means such that we will assure that first a child will execute, then a parent will execute? Do we have any means? Set priority. Okay, so if I set a priority, the problem is it depends on underlying operating system. If my operating system is not supporting the thread priority values, then it will be tough for me to go with this one. Any other ways? Yes, set priority is a one of option, but it depends on our operating system. That means first if we want to go with a set priority, first we need to cross check whether OS is supporting a set priority values or not. Right? So that is a one of option. Okay, we will accept. Any other options? Means by anyways we will give a priority for a child to execute. No ideas? Exactly, sleep method. Okay, so you can call a sleep method also, right? So what do you mean by a sleep? See, now here if I write sleep, right, if I write thread dot sleep, right, am I sending a my main thread to a sleep for some time? See, at the line number 21, I wanted to print a total, right? So now what I will do is, yes, child thread has started execution. Child thread has started execution. This has been executed by a main thread itself, right? After executing this, I will tell a main thread to sleep for some time, right? When a main thread will go for a sleep, obviously child will get a chance to execute. Obviously, right? Yes. Now, how much time I'll give her? So means we need to run this loop, right? So this loop need to be run means 100 times this particular statement need to be iterated, right? So what time we will give for this particular main thread to sleep? Shall I give some 10 seconds? Same answer. Good. In sync with the explanation. Okay. Let us check by just giving a 10 seconds, will it work fine or not? That means if a main thread sleeps for a 10 seconds, whether a child thread can finish its work or not. Just cross checking. Oh, it is saying unreported exception. What has to be done? It is saying that, bro, you are using a sleep method, so it will throw an exception. So throws exception. Good. I like this kind of response if you are giving in a chat box. It will increase our energy to explain the things. No errors. After a 10 seconds, we will get output, right? So I was thinking why it is not showing output. Got 50-50. Got the answer. Right? So 10 seconds was enough. Correct? 10 seconds was enough to finish this particular for loop. Right? Now, shall I? So means I have a small doubt, right? So it was waiting for a longer time. I felt like 10 seconds was a uh, bigger time for it to finish that particular for loop. Let me just check. Will it work for a 1 second? 1000 milliseconds in the sense 1 second, right? Okay. So let me just check. Will it finish the things in a 1 second? No errors. Wow, it is finishing in a 1 second also. So means 1 second, right? 1 milliseconds. Okay. 1000 milliseconds means one second. Right. I still have a doubt. Will it finish this one in 100 milliseconds? Will it or not? You should have a confidence. Yes. Tej Kiran is saying yes. Anybody? Maybe. Okay. Good answer. Oh. Anybody else? Yes. Right? So let us just cross check. Will it finish a for loop of 100 iterations in a 100 milliseconds? 100 iterations in 100 milliseconds. Question in a chat box. Sir, what is the logic behind the 50-50? This is just we are calculating sum of n natural numbers. So formula for a n natural numbers is n into n plus 1 by 2. So we are calculating for 100. So you can just calculate 100 into 100 plus 1 divided by n into n plus 1 by 2, right? So 100 into 100 plus 1 divided by 2. So that will be a valid 50-50. Right. So we are just checking will it finish its task in 100 milliseconds. No errors. Wow, it is able to finish 100 milliseconds. Let us just cross check. Did I wasted a much of a time of a processor? Just checking. Will it finish in a 10 milliseconds? Can't we write a sleep before creating a mythread object? Yes, you can write a sleep, but what is the purpose? Means before if you create a thread, if you are making a your main thread to sleep, who will create a child thread? If you have a two threads, then one thread if it goes to a sleep, then processor will give a chance for other thread to execute, right? If you are making a main thread itself to sleep, then who will create a child thread? Right. So now I am checking my output for a 10 milliseconds. Okay. So will it work or not? I have a reason why I am checking all these cases. I'm not getting. Sir, is it a question in the chat box? I'm checking. Is it possible for other numbers like a 1200 or like that? See, if you are interrupting this particular execution of a loop in between, then there might be a possibility of a 1200 or no, right? That is what I am checking. I am checking that I gave a 10 milliseconds sleeping pill for the main thread, right? So now a main thread will go for a sleep for a 10 millisecond, right? So during that particular 10 millisecond, I am just cross checking whether my thread will finish this particular loop of 100 iterations or not, right? So till now it is working fine for me. So let me just give 1 millisecond. Will it finish? Yes, it is finishing. That means if your main thread goes for a sleeping mode for a 1 millisecond also, your child thread will finish execution of a loop which is having 100 iterations. Is it not interesting? I am making my main thread to sleep for 1 millisecond, right? During that time sleeping period of 1 millisecond, my child thread has finished this particular loop of 100 iterations. Let me check one more value. 0 millisecond. Oh, where it went? 0 millisecond and a 1 nanosecond. I'm giving 0 millisecond and a 1 nanosecond. I just wanted to check whether this thing will be finished in that particular time or not. Yes, it is able to finish even in a 1 nanosecond itself. What was the initial value that we have given? 10,000 millisecond. When it has finished this one, less than 1 nanosecond it has finished loop, right? So whatever the remaining time was there, whether we have wasted that much time, is it feasible to go with the thread.sleep method? I am giving a 0, so means 1 nanosecond. I have given just a 1 nanosecond, right? So what a conclusion I mean to tell you is, when you are using a thread.sleep, you can make your main thread to sleep for some time and let your child thread will execute a program for it, right? So whatever job has been given for the child thread, you can allow that particular child thread to execute. But the problem will come with respect to how much time you need to give for your main thread to sleep, right? The problem will be, if you have a small, see, 100 iterations loop, it is executing in a 1 nanosecond. Then how can you predict based on a number of instructions how much time your main method should sleep? Not a feasible solution, right? Don't forget what topic we are discussing. We are discussing what is called as a inter-thread communication. Why we are discussing inter-thread communication means, if there is a requirement such that one thread is depending on another thread for the execution, then you require what is called as inter-thread communication. In our example, your child thread is calculating sum of 100 natural numbers and your main method is printing what is the answer of 100 natural numbers, right? So there is a relationship, or there is a necessity of a communication between a parent thread and a child thread, right? So we are seeing all the possible ways through which we can achieve the proper output for this particular jobs. Here, first option, as Suruchi said, we can go with the priorities, but a priorities is operating system dependent, so it will run in some system, it may not run in other system, so that was a drawback, so we didn't use that particular aspect. Second option, you can go with the thread.sleep, right? So the problem if you are going with the thread.sleep is, you will be in a confusion what time you have to give for a main thread to sleep, right? So because it is executing your 100 iterations for loop even in a nanosecond time of, so means nanoseconds of a time, right? We will be in a confusion what time need to be given for it to sleep. Shall we check a third option? Okay, right. So the third option is, you have a method which is called as join, right? You can use that particular method called th.join, right? So now what this particular join method will do, right? Whichever statement or whichever thread executes this particular statement will go for a sleep mode, will go for a waiting mode, right? So whichever thread executes this particular statement will go for waiting mode, right? Till what time it will go for a waiting mode? Till it finishes this particular thread. That means till this particular th, that particular thread. Th means thread, right? Till that particular th finishes its job. Be clear, don't get confused with respect to join method. Right? So who will be executing this particular th dot join? Obviously main thread. Right? What I said, whoever is executing this particular join method, that is a th dot join, they will go to wait mode. Right? So what is the indication is, there is a something called a join process need to be done. You wait for some time, let me finish, then you can join with the process. This is what a join method says to a main method. Right? Whenever a main method is executing th dot join, right? So that is an indication to a main method saying that, oh, this thread is going to do something. I need to wait for some time. Let it finish its work. Later we can join. Right? So it is something like you are attending a class. In the middle, you got some call saying that one person might be calling you to for playing some badminton or something. You will be saying like, so unfortunately today I am sitting in a class, and this is a bit interesting. So once I finish a class, I will join you. Right? So this is what you will be conveying, right? If you are interested, right? So the same information you are conveying to a main method. Right? When a main method executes a th dot join, it is an indication to a main method saying that main method should go to a waiting period until this particular th finishes its execution. Right? After it finishes its execution, you can proceed complete. So means you can resume back to your work. Is it clear with respect to join method? Shall we cross check whether the things are going to work fine if you are going to use a join method? Yes. If a join is working fine, then obviously we have to get an answer as a 50-50. Getting 50-50, that means a join is working fine. Right? Any disadvantages of using a join method? What is this, sir? You are only telling a solution, explanation, showing output. By the time we feel like, okay, so now the things are okay. So you are asking one more question. Yeah, we have to ask so many questions, then only the concepts will proceed further. And all these concepts are related. Huh? Any problem in this join method? Do you feel any problem in this? I feel there is some bigger issue to be addressed with respect to join method. Shall I tell the problem then? Okay, so what happens, what is happening exactly with respect to a join method? When you are calling a join method, your main method will be shifted to a waiting state, right? Main method is going to a wait state, right? Till what time it will be in a wait state? Until job is done. Until the job is done, it will be in a wait state. Correct? Until a complete process has been finished, it will be in a wait state. Right? What is my point is, when I say job, complete this particular statement is a job. Complete run method, whatever you have written in a run method, complete thing is nothing but a job. Correct? Yes. See, what is expected, what is required with respect to a main method? What was required for a main method? It wanted just a total value, right? Just assume that in this particular run method, you had some other statements. Some other statements are there. Some thousand statements are there. Like this, some thousand statements are there. Whether your main method should wait until it finishes all those unnecessary thousand statements also, when it is requiring only this particular answer. Main method is just required this particular total value, right? And this job, child job, idiot child job is executing all other statements, right? Once it got this particular total plus I, means total value, it can intimate to this particular person, right? Main method is waiting for that. It might have implemented that. It might have intimated that, right? So this is something like, I'll tell you an example. So means during a dinner time you are waiting for a chapati, right? So your mom told that, let me finish this particular chapati and then we can have at a single shot. So means later we will have, everybody will have a chapatis. Now if a family is of some 10 people, even if you are taking a 3 chapatis for a one person, 30 chapatis, that means you have to wait till mom finishes all the 30 chapatis, right? How much time she might take for preparing a 30 chapatis? Maybe some 45 to 45 minutes to 50 minutes, right? So you have to wait unnecessarily. You are not required to have all the 30 chapatis, right? You will be eating only 3 chapatis, right? So that is the reason why they will, what they will do, once one chapati is finished, they will notify you saying that yes, chapati is ready, you can have, right? But what a join is doing, join is saying that you wait for some time, I will finish my work, then we will proceed, right? So this is something like, let me finish all the 30 chapatis, you wait for some time, after finishing the 30 chapatis we will have a dinner. Will you agree with the join method? Am I able to showcase what is a problem with respect to join method? Right. So now what is the conclusion? And there will not be any twist. This will be a final twist. So there is a something called as wait method. So what a wait method will do is, when you are saying a th dot start, after this if you are executing a wait, then that particular thread will be waiting for its another thread to finish the work, right? So that particular child thread, whichever is doing the execution, once it finishes its execution, it has to call the method called as notify, right? So whenever a notification has been given, whenever a notify has appeared, so then easily it can proceed with the work, right? So, and one more important point what we have to remember is, you cannot use this particular wait method or a notify method directly, excuse me. Those methods should be part of your synchronized block, right? Your wait and notify methods should be under synchronized block, right? So using a synchronized block, you can make one thread to go for a waiting. When one thread has gone for a waiting, another thread will finish its execution. In whichever point you want that a notification should be given for the person whoever is awaiting, that will be notified to them, right? So let us see that modification by using wait and notify. Now what I mean to say is, here after this statement, I want my main method should go for a waiting state. I will be saying th dot wait, right? So as I already told you, this wait cannot be written something like this. If you are writing a directly wait without specifying a synchronized block, you will be getting an exception saying that illegal state monitor exception. That means you are entering into a illegal monitor state, right? So this is not a feasible. You cannot write a wait statement independently. That should be a part of a synchronized block, right? So let me create synchronized, right? So with respect to this object, okay. So now what I'm doing is, these statements I'm including in a synchronized block, right? So as per our theory, th dot start will occur. That means a main method will execute this particular part. So after executing, it will go for a th dot wait. Once main thread come across this particular th dot wait, your main thread will go to a waiting state, right? So when it goes for a waiting state, obviously this particular thread will given a priority. That means a parent will be given a priority. That means a child thread will be given a priority. So in this particular child thread, when you want to notify to the calling person, right? After this particular for loop, you want to notify, right? So you just specify based on a current object, whichever is awaiting, you notify to that particular person, saying that there is an answer ready for you, right? Again, this particular notify cannot be written independently, so I am including that one in a synchronized block. Sir, explain wait once again. See, now the thing is something means now the scenario is something like this. One second. Shall I remove these statements? One second. Remove the statements. Here, after this, I was having a system dot out dot println of whatever was the total. One second. Okay, so at this particular point, I want my main thread should go for a waiting state, right? I'll be writing th dot wait. Who will be executing this statement? Main method will be executing this statement. But I'm saying that the condition here is wait cannot be written independently. It should be enclosed in a what is called as a synchronized block, right? So that is the condition with respect to a Java, right? Synchronized in the sense what exactly it means is when this particular person is going for a wait, right? So how exactly the things will be working is main method will be executing this particular th dot wait, right? So now th will be under execution, right? So this particular thread will be under execution, and your main method, whoever has executed this statement, went for a sleeping mode, correct? It has went for a sleeping mode. Now the thing is, when it went to a sleeping mode, it says that it should not be disturbed until it gets a notification, right? So that is the reason why this particular aspect is recommended to go with a synchronized block, right? So what I mean to say is when a main method has a went for a waiting state, main method after executing this went to a waiting state, right? When it should wake up, when it get a notification, then it should wake up, right? If it is not in a synchronized block, there might be a possibility that some other person might be waking it up, right? So we are giving a protection saying that this is a synchronized. Once you are inside a synchronized block, until you get a notification for this, you will not be disturbed, right? So from where it is going for a waiting state? From a synchronized block. Within a synchronized block, it is going for a waiting state, right? So it will be in a waiting state until and unless you won't get a notification. Am I clear with the things? No, with respect to wait, you can use a notify. Join is a separate method. You cannot use a join and a notify because a wait and a notify is a pair. You will be having a situations where you wanted to go with a join also. There will be a situation where you are allowed your complete child through execute, then only you will finish with respect to a execution of a main method. In those scenarios, you can go with the join method. Okay. Now, once answer is ready, once this particular total is ready, I can give a notification for whoever person was waiting, right? So in my case, the person who was waiting was a main method, so he will get a notification saying that whatever the answer you are expecting that has been ready. Okay. So now let us just cross check Will I get output as a 50 or not? Cannot find a symbol t dot total. Who wrote a t dot total? Who taught in Java? Working fine. Understood wait method, notify method. Okay, so before I give a time, similar to notify, you have a one more method called a notify all also. Okay, notify all in the sense whichever thread is under a waiting, for all those threads, notification will be given saying that the task has been finished. Right? If I am using here notify all, then there will not be any difference because there is only one thread under a waiting state. So if you have a number of threads who will be expecting a same answer, right? So there might be another thread which will be printing this particular total itself, right? Or there might be another thread which will be calculating after getting a total, it might be calculating average, right? So to give an intimation for that thread also, instead of using a notify, we will be using a notify all. If you want, I'll share an example with respect to notify all. You can go through that. Once you are clear with the notify, then it will not be that much difficult to understand a notify all. Any questions? Question in the chat box. Sir, what if we won't write notify? Will it execute all lines of code? Let us just cross check. I have written it as a synchronized block. Let me comment this particular notify method. Let us just cross check. Working fine. Problem will not come now. Problem will come if you have any other statements with respect to that particular job, right? So it will take a longer time for it to execute, right? Here notify is not there. Notify is not there means it will proceed with the execution of a further lines, right? So when it is going a further lines of executions, obviously it is waste of a going with the wait method only. Rather you might have gone with a join method only, right? So when our intention is to allow our job to execute completely without any interruption, then don't go with a notify and a wait kind of a combination, because you are explicitly writing a synchronized blocks for those methods again, right? If your intention is to allow your thread to execute completely, right, then go with a join method. Hope I made it clear. No questions? Okay. If you don't have a question, not to confuse you, again I'm telling you, just to give you a clarification, let me add a one small statement. Even I'm not sure like how exactly the output will be, right? So let me add a small statement here. The statement is something like this. What has been done, it is up to you to understand. I'll just run a program and I'll show you output. See, still your process is under working itself. It is not showing the output only. What has happened? What extra thing we have added? Thread dot sleep for a 10 milliseconds. 10 milliseconds, 10,000 milliseconds. Main thread went to sleep. Right? Problem in this case was main thread went to a sleep. When the main thread went to a sleep, 1 second. When a main thread went to a sleep, how much time was required for your child thread to finish 100 iterations? Some nanoseconds, right? What I mean to say is main thread went to a sleep, right? When a main thread went to a sleep, thread was started. When it was started, will it keep idle? It will not be idle, right? It has finished its execution. It has finished the calculation of this one. This calculation has been done. It has a notified also, right? It has notified also, but this idiot, that main method was in a sleep mode. It was not ready to accept that notification also, because it has not executed a wait itself. And it has not executed a wait, obviously it will not be aware of a notify also, right? What's happening internally is main method was sleeping. When the main method was sleeping, child thread has finished its execution, right? When a child thread has finished execution, after a 10 seconds, this main thread came back. You told to wait for a 10 seconds, right? After 10 seconds, it came back. When it came back, you told it to wait. Wow, what a idiotic stuff we have done. You told it to wait, right? When you told it to wait, obviously it will wait. Till what time it will wait? It will wait. See, my network was gone and it has reconnected again. Still, it is showing a one task. That means still your main method is waiting for notification to be delivered by a child thread. Clear with the stuffs? Not to confuse you, better, so it means to give a better clarity to you. Right? So if you want to avoid this kind of circumstances, you can specify for a wait also some time, right? You can say that you wait for some 1 second, right, or 10 seconds. During that 10 seconds, if you won't get any notification, you can proceed with your work. You can print whatever is the th output. Understood? For a wait, you can pass how much time it has to wait for also, right? So that's it from my side. Once again, sir, but after 10 seconds, it is again waiting for a notify. You mean to say after this particular wait of 1,000 seconds, 10,000 milliseconds? No, here whether it is getting an answer or not, it will be waiting for 1,000 milliseconds. Means that particular 10 seconds, right? Within that particular 10 seconds, if it is able, means it is just waiting for 10 seconds. Now it is up to the responsibility of a child task to finish its task in that particular 10 seconds, right? After 10 seconds, it will be active. It will proceed with a further statements. Right? So what was the problem is, if I was not giving any value, there might be a chance that it might be waiting for a longer time. See, still now it is waiting. See, it is showing a task, one task. That means it is still under waiting. It will never get a notification. It will be in a waiting state itself. Right? So to avoid certain those kind of circumstances, you can give a value for a wait also, explicitly saying that this is a time period for which you have to wait. Hope things are clear. Any questions? Sir, during main method sleep time, child thread has sent notify. Then again in a synchronized, it is waiting for a notify. Yes, notification has already given, but that was not known for a main method. It was a sleeping that time. When a notification was sent after finishing a loop, when a loop has been finished, within 1 nanosecond, it was a finished. How much time a main method is sleeping? It is sleeping for some 10 seconds, right? When a notification has been released, even in a nanoseconds, that time it was sleeping. It is not aware that a notification has been given, right? So child has finished its work. It has finished its work and it has went to a dead state also. Now this person has woke up after a 10 seconds looking for a notification, right? So he will not get a notification. He will be in a waiting state itself. Even if I take a class for some 100, means 1 hour also, it will be in a waiting state only. Right? So So that's it from my side. Have a nice time. So go through the recording carefully and be clear with all the points.